All right, so welcome to Valentine's Day. For those of you in here, did that help actually moving like the land school so you guys could see the code a little easier? Was that helpful? Okay, so I will actually share out my screen then with you guys here in class. Let's window it so you guys can move it around. Did that actually show this one on the screen? Sweet. All right, we figured out our weird issue. The land school doesn't let me pick back and forth, which is always interesting. So really quickly, a couple of things we talked about is we talked about the idea of modularization or making these modules, subroutines, methods. There's a lot of different names we use that are very, very similar. So almost every programming language has it, and so we can write it in pseudocode. And so we have some examples where we have repetitive structures. And anytime we repeat something, so in this program, notice how HIJK, HIJ, HIJ, we have repetitive structures. We could actually write a module to take care of that. And once I use it in one program, I may be able to use it in other programs. I may be able to use it standalone. I may be able to use it in several programs, several pieces in my program. So it gets around that idea of we're doing things over and over again. We can make our lives a lot easier. So there's a couple of terms in this book that you need to be aware of. And so one of them here that they pop out is called functional cohesion. Functional cohesion. So what we're trying to do, what that really is all it's saying is our method that we create, our module, everything should really be doing the same thing. So we could write a module that was very coherent, very functional, and then we started adding lines that didn't seem to make sense. That's that idea. So we'll look at that, and so we'll come back to that idea of functional cohesion. We're going to make them ourselves very, very functional. So the other piece we need to talk about is something called scope. And that is, where does that variable see each other? Where can I see the variable? And ideally, we want these modules to be completely self-contained. So all the way to the extreme of if you're writing software that deals with something that's very personal, very private, that we need to keep secret. So social security numbers, your NUID number. It only exists inside of this module. And we can only see that variable inside that module. So it makes us have to do a couple of things, but we only want data visible within a method or the program in which we declare them. So I'm going to declare a variable here. So let me start Notepad up. And let me go into the format and make this a little bigger, so it's a little easier to see. 24 should be giant in here. So we're going to declare a program. So I'm going to do my start. Down here at the bottom, I'm going to do a stop. Now this program, we don't know yet what it's going to do, but I know I'm going to have a couple variables. And maybe this program is going to take in a name and do a little bit of searching for it. So we're going to declare a variable. We're going to declare, and I'm going to actually just spell this out. Normally we wouldn't, just so it makes it a little plainer. Declare name as a variable. And remember, we're in pseudocode, so I can do these kinds of things just to make life easier, but I want you to see that name. So normally we would just say it's a string name, and then we'd set it equal to a blank value. But in this case, I want to see that we're declaring this name up here, and we're declaring it in the program itself. And I know that I want to have something to input that name and to do a little bit of value checking on that name. And so I'm going to write a module called input name. So my module, so anytime I have a module, it's not in the main program. It's either in another file, or what we're going to do is it's outside of our main program. And so we're going to declare this. So we're going to have a declaration again. So we're going to declare module input name. So normally we're not going to go to quite that length, but I want to see if we can make some sense of this idea. So when I declare this, I can then put in, so I'm going to indent one and I'm going to put output. Please enter your name. And then I maybe even am going to do a while loop. So while bigger. So then we're going to have an input. Input name. And then while name is equal to blank. So in case somebody puts in a blank value, so they just hit enter, we don't want that. We know that's going to mess up our program. We're going to have it seems you didn't type your name. Input name. And so now that loop, so notice what's going to happen. That loop takes in a value. It says, hey, here's a name. If it doesn't equal anything, it's going to loop this forever until you actually put in a name. So it's going to force you at some point to put in a name. And then we know that every module has to return something. So we're going to just say return for now. So we don't care about this program. And in fact, I'm going to eliminate this right here. And I'm going to declare this name down here at the top of my module. So I'm going to say string name. And I'm going to set it equal to a blank, just so we flush out whatever's in there. So now that variable is only inside of my module, right? So my program, I don't even know what's in here. Don't have a clue what we're going to use it for. But to run this program, it's going to be called input name. And so I'm going to declare a value up here, and I'm going to call it user name. And I'm going to set it equal to blank. And it's going to be a string. Now, when we do in Python, what you're going to see is we don't even have to declare that, but it makes it kind of a clear method that we see we're doing that. So I now have two variables. I have username up here, and I have just name down here. And so in my program then, I want to get that name, and I want to run that module. So I'm going to say user name is equal to input name. Now, that's not all the details yet. And when we start working with Python, you'll see we have a few other pieces in there. But what's happening is this value down here, this name, I can't just access it up here. I have to actually call this module to run. So that's what I do. This, we really are going to say return name, because we're going to return that value that's in name and push it back into this program. And so it's going to take that name out of here, whatever we get, and shove it up here and then slide it into that value, into that variable. That's one way we can move that value from one variable to the other. Because right now, if I just said, maybe I didn't have that line in there, and I just said output name, it's going to give me an error and say, hey, you haven't even declared that variable. Because that variable is declared and only available inside of this module down here. So I have to come up with a way that we can pass some of those variables back and forth. And so now I've done that. I said, okay, so username equals that input. And by putting those parentheses, it tells me that we're running a module. we could have another module. You don't have to have just one in a program. So maybe we have another one down here. And we have a module, so we're just going to declare module scramble name. And so in this case, we're going to pass a variable into the function. So now we're actually going to put a variable in the other direction. So we took a value from a function and pushed it into the main program. Now, maybe we're going to take a value and we're going to push it into a function. So we could say scramble name, and we're going to put in username, and we're going to call that function that way. And so maybe we need another name for it because we want to get a value back also. Or do we just print it out of our module? We can do it either way. So we don't know yet how we can scramble a name up. So we're just going to call it some function to randomly scramble name. And that name that comes in, username, we probably need some internal name for that. So we could call that scramble. And we're going to scramble that name up temporarily. And so we could just say output scramble. So we wouldn't even have to go back into this. So our entire main program is really only a couple of lines long. So these modules let us do something. And if I'm going to scramble a name, so maybe this is a security function to randomly scramble your name up, I can do it over and over and over and over again. So every time I call that, so if I put this in the program 10 times, it's going to run that module every time we do that. So that's part of that modularization. And maybe we've written a really clever way to scramble up a user's name. And again, maybe it's a username, NUID, something like that we need to protect. So we pass it off into that encryption module or a scrambling module to hide that data. And we can run these things over and over and over and over again. So if we look at in our book, so that's what they're talking about, that idea of scope, is whether it's local or, so it's either in the module, it's either in the program. There is a way to do that for both, and it's called using a global variable. And a global variable, if I declared something as global, so string username, and we're just going to call it a global variable. And how we do that depends on the particular language. If we declare it as a global variable, I can use it anywhere in the program and in the modules. And so that seems like that would be a great shortcut. But the reality is we break these into modules for a reason, and a lot of times I don't want things available everywhere in the program. So think about MyPSC. If a variable was available anywhere in MyPSC, so financial aid information, that's private information that we don't get to see. Only the financial aid office sees. And in fact, it's one of the few areas where your social security number is still in our system. Social security number by the federal laws has to be used to identify you for your financial aid. If we made those variables in there global, we could get to them from anywhere. So we put a query in and we said, hey, I want to see about your classes, and I put in something wrong, and now all of a sudden I see your social security number. We don't want that. If I keep it contained to just that module for financial aid, then I don't have to worry about it showing up in class registration. So we try to do these things, and we try to make them as modular as possible. So they talk about being passed by value and by reference. So we get a way that we can pass those values in and out. So We also have to deal with how we pass data in and out. I'm more worried about, can you figure out which things need to come into a module, which things don't come into a module. Now, the other thing that you're going to see is very similar to what you're doing here, where we're going to have to write them. Almost every language has a whole bunch of routines that are already built in, that are predefined, that we can use. So for example, Python has a random number generator built in. It's one of the library functions that you can include with Python. And so instead of having to rewrite a whole program how to generate a random number, we can use a built-in function. And so I could say random number equals my Python random function, or whatever it is. And there's some other pieces to that, but we can use default ones. We can write our own. So our main program gets very, very short. It's really down to that logical sense of our program needs to do A, needs to do B, needs to do C. The details then we hide in these modules. And in a lot of cases, we can reuse and rewrite those modules over and over and over again. So if I look at, let me find the right one. So our book has a couple of things that we can look at for problems in here. So move that out of the way. So we're doing number 2A, and only A. I will say one of the keys for A is make sure that there are 2 functions in there. So you're going to do that, generally 2 functions in that one. So let's take a look at number 3. So 3 says create a logic for a program that continuously prompts the user for a numeric number of dollars until the user enters 0. Pass each entered amount to a conversion method that displays a breakdown of the past amount into the fewest bills. In other words, it calculates the number of 20s, 10s, 5s, and $1 needed. That's an interesting problem, isn't it? So let's think about that in a couple of ways. How do I break down values into number of bills? So let's do a couple of things. Let's set this one. Let's just delete all of this. And let's think about what we're trying to do first. So this program, the user inputs, a dollar amount. We're taking that dollar amount, bless you, and we're converting that to bills. So if somebody comes up to you and says $137, how would we convert that into the greatest number of bills? How would you do that in your head? So let's work through that logic, how you would do that in your head. How would I convert that to bills? So you can use 50s, you can use hundreds if you wanted to. So it might be easier if we limit ourselves to 20s, 10s, 5s, and 1s. Just because it's a couple of less values in there. But the same logic is going to work. What do I do if you said, somebody walked up to you and said, I need $137, and you opened up your billfold? How are you going to figure out how much money to hand them? So I'm going to use the number 137, and we have available, so only bills 20, 10, 5, and a 1. That's the only bills you have available. How would I figure out what to give the user as an output? So how did you come up with 620s? Is there an easier way to do it? So we could add 20 until it goes over that value. Okay, so there actually is an easier way we can do that with almost every programming language. So what we can do is this. In fact, there's a couple of different ways we can do it. We know that we always want to start with the biggest bill, right? That makes sense because we want to put them in the biggest bills. Because the other reality is we could just hand somebody $137 in ones. That's just going to look really weird, and why do you have $137 in ones? But what we really do internally in our brain is we divide. Does that make sense? We divide in our head. And so we can do this with our program. So we can have it divide. So we could say, all right, here's my input value, and I want to divide it by my largest bill, which in this case is a 20. And what's that going to give me for a value? If I did that on a calculator, what number am I going to get? Well, you can put it in a calculator and you can see. So 20 or 137 divided by 20 is going to give you 6.85, right? Which part of that number do we need? Do you think is important? The 6. So we can actually use a couple of different math functions to get that. So we could say we just want the integer value of that. So we just want the integer value. The problem is it's going to round it up to 7. There is a math operation called the modulus. Have you guys ever heard of the modulus? Ooh. So what does the modulus operator give us? You guys can use Google. It's your friend. So we need to figure out a way so we strip off just that first portion, right? So there are a lot of different ways we can do it. There are a lot of different ways we can do that. The way I would suggest is we just magically make up our own function. We're going to call it take the integer piece. So in our case, we can do that. If I just take the integer, I'm going to strip that off, right? And so I need a variable in there, so I'm going to say I have, so maybe in here we're going to have some variables. So we're going to have 20s. We're going to have 10s. We're going to have 5s. And you're going to have 1. In this case, once you see that, once you say, all right, input divided by 20 equals 6, and we're going to take it times the integer function maybe, and we're just going to hope it works right. We'll see if it does or not. So we're going to take the value of that integer. I can then assign that. So really we do it the other direction, wouldn't we? So let's do it this way. So we know that this is 20s equals our input divided by 20, and the whole thing inside of another function. Did we have to create that integer function? No, it's already there for us. It's already there based in there for us. Now that we took the 20s out, does that make sense? We should have 6 20s. So I'm just going to duck it up here so we can see what happened. So what do we need to do next? We need to do the 10s. So that makes sense. So 10s equals integer of input divided by 10. Wait a minute. Did that input change? So right now we would actually say we're taking the 137 divided by 10. But what should that input now be changed to? So we need to have another line in here that would say input equals input minus 20s times 20. All right. Does that make sense? So we're taking out that $120 back out of it. So now you really should have, if I added right in my head, you should have 17, right? So how many 10s are we going to have? Just one, right? And so we do the same thing. So that logic of input equals input minus 10s times 10. And there are far more elegant ways to do this. So now our input is down to $7, right? So we could say 5s equal integer of input divided by 5, right? And so you do the same thing. And that should give you 1, right? If I have that correct. And so then we have to change our input again. So input equals input minus 5s times 5. And then we do 1s equal value of input. Do I need to divide by 1? It should be the right number, hopefully. And hopefully that is 1 and 1. So this program, what we're writing here, that looks like that would be a great module, doesn't it? That might be a really great thing we could run as a module. Because I want to figure out how we can run something in a program. So our logic up here is still sound, so I'm going to leave it up so we can see it. So I'm going to start our program. And we're going to have a bunch of declarations. So we're going to have to create a bunch of things out here for this module. So in our module, we're going to have to declare a value for 20, so numeric 20s, and set it equal to 0, 10s equal to 0, numeric 5s equal to 0, numeric 1s equal to 0. So we're just doing a little work here building this module, because this module is going to get a little long. It does one task over and over again, but it does seem to get a little long because we have all those variables in there. We also are going to have numeric for input, because we're going to use that variable in there, right? And so we might as well give this a name. So we're going to call this declare module Bill. Maybe we'll call him Bill. So we've got an input, 20s, 10s, 5s, 1s. And maybe we have an output statement. And we have output, you have, and then we need the number of 20s, $20 bills, output and then we could just copy that because we know it's very similar. And so we're going to have a whole list of output statements of tens, $10 bills. So we could have that whole set of outputs, right? So it's going to output that module. Where do I see something like this? Where do I see something that tells you exactly how to give change back? A POS system. McDonald's, somewhere where we're getting change. So you have this entire module out here. We're going to say return at the bottom. Could we write this to actually go all the way to quarters, nickels, dimes, and pennies? Would it work really any different? No, not really. You're just taking the larger bills, dividing out how many you have. Now you'd get to the quarters and you'd have to do a little math modules. And we could show you how to do that, but you're just dividing by the largest item that you want. How many of those can you fit in each one? So here we have that output then has 4 different lines, and it could have all kinds of handy things in it. So our module gets bigger and bigger. So here's our 10s, here's our 5s, and our 1s. And I'd like to point out that in this particular module, the way it's written, that even if it screws up, it's only going to say, hey, you've got 23 ones. So if you have an issue, it's always going to come out at the end because we set it equal to whatever that value is left. But that module's kind of long. I wouldn't want to write that in my main program because I may want to use that over and over again. So we know what our values are up there. So I'm going to come up here and I'm going to create my program. So I'm going to have start and I'm going to have stop. So now we can deal with that main logic. We don't have to care about what the value for change is in this module because we're going to pass it off into a module of some sort, right? So now we could have customer pays with whatever. So we could have a value for customer. Let's create that as a numeric. If I get my cursor in the right one. Numeric customer pay. Set that equal to 0. Numeric for bill. I'm going to set that one equal to 0. And we don't know what those numbers are going to be because maybe there's a module for computing that. But what I know is we're going to pass into something. So we're going to say while change is not equal to 999. We'll use 999 as our sentinel value. And so we need another one for change. And from some other place in this computer system, it's going to get a value for change. We don't care where. So maybe it's the point of sale module running out to this module here. So we're going to get a value for change. While that change is not equal to 999, we're going to run module bill. And I'm going to pass in change. So now it's going to call this module called bill. So no matter what that value, as long as it's 999, it's going to go out and run this entire module. So you could have all kinds of pieces in here. So this is where you could put in output. Thank you for shopping at Shopko. And you could have all different kinds of things. But once I have this designed and I know this runs, I can plug it in anywhere in that program. And so right now, we don't know where this input comes from, do we? They could be manually typing it in. It could come out of another program, out of another module. Maybe that comes out of some magic pie in the sky. Doesn't matter. As long as that value is not equal to 999, we run Bill. There's one other piece we need in there. Because right now our loop doesn't ever have another input. So input change, so that that sentinel value has a chance to change. And that program would actually run. And it would not matter where that input came from. So now if I'm thinking about this as a point of sale program, could I write a module that totals up their entire bill first? Yeah. So you could create a module, and your module up here might then be order. And so it runs this particular module, and then that generates that change value. So this is the way we write most programs. We don't write one program straight through from end to end, because we find that a lot of those pieces repeat over and over and over and over again. So this gives us the ability then to put things into smaller pieces. So let's look at our number 2 problem. Make sure I don't cover what I've already talked about here, because there is actually a homework help option in here also. So if you haven't looked at that, there is a video linked in here. Homework hints, tips, tricks. So we talk about public and private access in there. So make sure you look at that. We're going to look at it again, though, really quickly. And this one says, create the logic for a program that performs arithmetic functions. Design the program to contain 2 numeric variables. Prompt the user for values for these variables. Pass both variables to methods named sum and difference. Create the logic for the methods sum and difference. They compute the sum and difference between the values of 2 arguments, respectively. Oh, interesting. So you're creating a program that's going to take 2 values in. So that one should be pretty easy. We can write, let me just delete all this really quickly. So you know you're going to have a start. You know you're going to have a stop. You know you're going to have a module, one called sum, and that's going to have a return. You know in this case you're going to need a module called difference, right? I think it is. And it's going to have a return. We know that both of those programs, so when I look at the instructions, it says create the logic for the methods. They compute the sum and difference between the values of 2 arguments. All right. So prompt the user for variables to contain 2 numeric variables. So in my program, how am I going to get a user to input a variable? What do I do? So I probably have an output. Please enter first value. And then an input. And so we probably are going to have a couple of values. So we could just call them value 1, value 2. So we know they're going to be both numerics. And we know we could set them equal to 0. Kind of a quick housekeeping. Please enter first value. And you could say input value . So we could then say, all right, well, we know if that's going to work for value 1, why don't I just do this? Copy and paste. Change that a little bit to say second and to value 2. So that's the easy way to do that. But is that perfect yet? Is there any problem with that? No problem with it? What if they put in ABC? Oh. So we need to probably put these into some kind of an error checking. In this case, let's just assume that the world is perfect and we don't have to do that. The error checking is already in there somewhere else. Or we put that into another module, which is most of the time what we would really do. So we have two values. How am I going to call module sum? What might I do? So down here I'm declaring the modules right here. So we need to pass in two values into it. How would I pass two values into a function? Ooh. You do put it inside the parentheses. So sum value 1, value 2. And generally we have to assign it to, because what I'm hoping is that you return a value. And in this case, you're going to return something. So you're going to return what we're going to call the module sum. Let's just call it, product would not work. Let's call it return some value. Now here's where it's a little weird. I'm going to do the same thing for both of them. Return some value. I can't just say that I can get some value. So up here, I'm going to set it equal to something. Value equals. And so up here, I need to declare that variable also. So this module is going to return something inside here. Oops, come back to me. Inside of here, it's going to create something called some value. And it sends it back to this function that we're going to recall it and says, all right, here it is, and shoves it into value. They're different variable names. You notice that? Now, to make it confusing, we could use the same name because they can't see each other. The values in this part of the program can't directly see the values here. We have to pass that value into that function. That's why up here we said we're going to pass in value 1 and value 2 into this function, and we send it in here. So inside of our module, inside of that module, we're going to take in value 1, value 2. But they can't see each other directly. So we could actually call this, if you wanted to, X and Y. And I might do that just so I make that point of this value cannot be seen directly down here.
But usually do you just leave the parentheses as it is?
On which one?
Like for those modules?
For the modules like...
below the stop, yeah. Do you usually just leave them, the parentheses blank?
No, if you're putting in a value, it's got to be in there. If you're passing a value in, you're going to say you're passing a value in. So this tells me that this module gets a value passed in. And in this case, it says it gets two values passed in. Here this says we're passing that value in, whatever that might be. So if we hadn't created those values and we just hard-coded them, maybe that's 15 and 25. Does that make sense? When they come down here then, X and Y are equal to 15 and 25. So now we're inside of this module What does that module say it's going to do with this? It's going to create a sum. So sum value is equal to x plus y. Now this one's not particularly sophisticated, but now I have a value for that. So I do need to declare that value. Numeric sum value equals 0. I have a value, so here's my number. So now it says 15 plus 25, so hopefully that's 40, is shoved into this variable. And this variable gets returned back up to this function here. So that value of it, so 40, comes up here and gets shoved into value. And so if then my next step is output value, I'm going to get the result of 40. So again, this one's a little silly in that we're just doing a simple math function, and we could put it directly in the program code. But imagine if we did all kinds of other things to this function. So maybe it ran, like I said, an encryption code on there. It's the same type of detail. So now we're gonna take those values and it's gonna shove it back out, and you can then use that value later on. So if I can do that for a sum, what's the other one we're doing? A difference is going to work exactly the same thing. But I could even do this where that input and outputs now become part of a module. So all we're doing is trying to figure out how we break those programs down and make them as user-friendly as possible. So ideally, what we're going to end up with is our program is going to look like this. Start, stop, and it's going to have an input module. It's going to have a math. You'd have your sum module, your difference module. Your whole program is just going to look like that. And that way you don't have to think about how those things actually work at that detail level when you're constructing that logic. You know, hey, I've got an input module I'll use. I'm going to run it through the math module to do the sum, the difference module to do the difference, and I'm done. So look at the logic of this. You have essentially a 3-line program eventually versus having to do all of these items. So those modules, once you start creating for things like input a name or input yes and no, we do that a lot, then it's a module. We don't have to come up and write all that code in here. We just say, oh, yep, I need a yes or no answer out of the user. Let me send it to that module. So this isn't very pretty. So input value 1, input value 2, output value. So you could pretty it up and you could say, you know, something like output the sum of value 1. And notice what I'm doing there is I'm letting it put the actual number in, and value 2 is, you can do something like that to show that you're outputting that in the right order. So you can make it pretty and make it look like it does a lot of things. But this is half of your problem right there. We've broken it down into a module. The math module molds it. But understanding how we pass those values, that's the hardest part of this. So in here, let me go through this again. So in here, we get two values, two input values. We just called them value 1, value 2. We put them, value 1, value 2. We put those in and said, all right, we're going to pass those two values, whatever they happen to be, into this function for sum. And we're going to send it down to this module. And we're going to say, all right, so down here, we're going to create another variable, and we're going to add those two together. So x plus y is equal to some value. We take that number, and we return it back up here to this program, and we kick it out.
So in the module down below, you don't have to say like output value or anything. That's just what the return does for you.
The return passes it back to the main module. You could put the output down there. It depends on what your intent is. If you have an output module, so we could actually have, if you really wanted to, so you could actually pass this, instead of an output, you could actually have a module called output. So I'm just going to call it so it makes it sense, output. And output's going to take in, we'll just call it x, because it's going to get one number and we know what it is. And that module is going to output x and maybe another line or something, whatever it is, return. And notice I don't have anything it's going to return. It's not going to return a value. It's just going to print that statement. So instead of here where we had an output, the sum of, and I could just run that module, output, and now we know that we're going to pass in that one called value that we got right up here. And that's how if you think about it, when you create a function to go to a printer, you're passing it into a function for printing. And so that's doing essentially the same thing. So now we added a module for output. Because I don't want to have to think about in my main program, I'm going to print this or output it. Do I care if it's going to a laser printer or an inkjet printer or where it goes? No, I just want to output it to a printer. And so that's what the beauty of those modules is. They take care of the details for us. We write the details in the modules. That abstract thinking of I walked forward, I turn left is in the main program, the big picture logic. So our build program, how we break those into smaller pieces. So that way all the items that stay inside of there, so anything we're only passing out to that printer, that output. We're not passing anything else to it. And that module then could check to see what kind of printer it is, what kind of display it could do, whether it can do color. All those details we don't care about in our main line. All our main line is we say, hey, we're getting two numbers, we're adding them, we're subtracting them, and we're printing out the results. So this is probably a little confusing. This is a confusing piece until you start using them, I think, of why we break those up. But it's to get rid of those details. So you don't have to think about every little detail when you start breaking down a problem. So think about it in terms of, I'm going to go to a concert. When you say, I'm going to go to a concert, you first start doing the big picture items. What date is the concert? What is the price of the concert? The little details, those, how am I going to get to the concert? What am I going to do while I'm there? How am I going to get home? Those little details are those modules. So the modules have all those details plugged into them. So we break them in. The passing of the values is a little tough and a little foreign. We have to explicitly say we're going to send a value into a function. They can't see each other. And that's good. We don't want them. So if I just open up this program, I don't want to be able to see the values that are inside a function. And if I think about it in terms of security, think about it from that standpoint. I want those functions to be able to be standalone. The data inside of them, I want to send data to them and pull data out. I don't want that data inside to be visible. Think about a password module. If I send data into something that says enter your password, I don't want your password and how you get it visible everywhere inside my computer system. I only want it inside that password module. You do not have to do part B. So I think in some ways this should be a lot easier than last week's homework. So create a logic for a program that performs functions of math. Two numeric variables. You're going to have two functions called sum and difference. Now, could I make this fancy? Could I then ask for multiple inputs so I could create this in a loop? And we could have it where they ask for 2 inputs and then it says, oh, now what are your next 2 inputs? Yeah. But what I'm really looking for is breaking this down into that idea of modules. All right. So on top of all kinds of other modules, I have in your chapter this week a couple of things. So make sure if you haven't looked at the solution for last week's problem, make sure you look at it. There is some samples of some other code so you can look at for modules and other ideas that are in there. I will send out more sample code if that helps. Being able to read through a piece of code and say, oh yeah, I see what that does. That's one of the keys I think in here. So we can do some other ones. So I have one that's a little more complicated that does a similar type of function. Now, this one does some things we have not talked about yet. But I think if we look at it, you can figure out what it does. When I say here we have user's choice, we know that that's a number that's being declared. Output, enter a number, and input one called user's choice. It then gets a function called multiplication table and takes whatever number you put in and sends it to that function. Now, we haven't talked about why we might call this a void function, and I'm not concerned about that yet. This takes in that choice value. So if you put in 10, it's going to take 10 and bring it down into this function. That's now called value. Remember, we can't see them directly. This one has a low, has a high, has an X, an answer. It's got a lot of value pieces in there. So we set X to low, and while X is less than high, so we're going to go between 2 and 10. Does that make sense? We're making a loop from 2 to 10 where X is going to change, and it's going to put out our value times number. Well, it's going to give us that every time. It's going to give us a times table and build a times table up from 2 to 10 where our number is in that times table. Then at the end of this, it says return answer. All right. But we don't actually take it in and do anything with it. It just returns and that's why we call it a void. It doesn't actually return anything that we use. So that's another example of one with a module. And notice, all we do is we know that we're going to do a multiplication table. We don't want to have to think about all these details when we create our logic. We just say, oh, yep, we're going to get a number, and we're going to create a table. So our main logic is pretty simple, and then our logic inside that module, that's where we have to deal with the details of how we're going to create something. So if we would have thrown this up 4 weeks ago, you guys would have looked at that and went, I don't have a clue what that's doing. And now you should be able to read through that code and say, hey, I can work my way through this. I can see what's going on. I know that, hey, it's capitalized. That's probably a, what is it when we capitalize in all the letters in a variable? It's a constant. We don't change it. And we know that indenting, that it says, hey, this block, all these things in here are part of that declarations block. All of these items are what's going to run inside this while loop. I know this is challenging. I know this is different, but it's something we want to get to. All right, so Python. Make sure you have went out and you have installed Python. And again, the world's greatest site, python.org. I very much thought about just using this website instead of a textbook for the entire class. But it doesn't go into those constructs about what is a loop, so I wanted you guys to have something tangible to hold on to. There are a lot of resources here. Make sure you have downloaded and make sure it runs. And when you run it, so if I click the Windows button and I type IDLE, because that's what we're going to be in most of the time, it should pop up. And you need to make sure that it says it's 3 something. It doesn't really matter. If you get an older version or a newer version, as long as it says 3 dot something for this class, you're fine. If you manage to download the 2 version, or it's already on a computer, you need to download the 3.x version. The 2 and the 3, there's a big fork in it, and so it depends on, there's a lot of existing code that was written in the 2.x standards, but we're going to use the latest standards, the 3.x standards. So new stuff is all written through this. The existing standards exist, or the older standards exist just so we can maintain older programs and look at them. So you want to look at this. There are 2 pieces to this, and this again is where some students get a little confused. Normally, I don't put in, I can put in a print statement right here. And I can run a load of code, and notice it actually did what I told it. Well, I don't normally run from this environment. But if I go click up here and I click File, New, now it puts me in a batch mode. I can create, and notice this looks almost exactly like our Notepad. And you can actually use Notepad and other editors, and we'll show you how to do that. And now I can put in multiple lines, so I could say print and print hello world, and I could run this file. This is much though like when you're working in web design or other classes, we have to save this file before we can actually run it. So I'm going to save it. Your files, just as a reminder, are .py. And so when I click run and it saved it, now it puts it up in this window and says, hey, there, I ran your program. Hello world. Not very exciting yet, but we're going to get there. So you need to make sure that you can get to this and that you can click File, New. You will also probably want to pick somewhere you're always saving your files. So if it's a flash drive and you bring it to class every day, or you're saving somewhere specific every time in the same folder. That way you know where it's at and what it's doing and why it's there. Again, they're all .py files, so if I were to look for that, File, Save As. So if I save that on my desktop, for example, I see I've already got one called .py somewhere on here. So it's got a weird little symbol, looks like that. And I can edit it. Notice if I right click, I can edit it. I can edit it with Notepad++, so there's a lot of other tools that we have available out here. And in fact, it actually runs if I just click on it, but notice it disappears immediately. I haven't shown you how to fix that little issue. So these programs actually will run directly, but we don't have any way to hold it open. It ran, and then it closed. It printed it out and says, oh, you're done with me, I'm going to close back up. So we'll show you how to hold those open if you want to create one that actually runs that way also. All right, any questions off the top? Going once? Going twice? Going 3 times. All right, remember, if you have a question, email me. Send me a code snippet and say, hey, does this seem like it's right? And I'll try to reply back as quickly as I can.